In the last video, we started talking about inequalities in triangles, where if you're given two sides of a triangle, that the last side was limited to a size. It could not be overly big or overly small. It had to be in a certain range. And I want to do a couple more examples of this. And so, here we go. This will be like an extra example 1. And let's say that we've gotten a triangle that has the side lengths of 4, 9, and 10. Now recall from the triangle inequality theorem, it said that the sum of any two of the sides has to be greater than the side you didn't add. So let's try this out. So we say, okay, well, 4 plus 9, and the side we didn't use was 10. Then maybe 4 plus 10, and the side we didn't use was 9. And simply the last one of 9 plus 10. And the side we didn't use was 4. So if we add these together and get a value that's greater than the side we didn't use, then it will work. And then we do it again, and it will work. And we do it again. And if it works, then we can conclude that yes, this could form a triangle. These side lengths will indeed be a triangle. So let's try it. 4 plus 9 is 13. Okay, 13 is greater than 10. So that's good. 4 plus 10 is 14, and that is indeed greater than 9, so that works. And then 9 plus 10 is greater than 4, because that's its value of 19. So we got all three of them to work. Therefore, these side lengths would indeed create a triangle, because the sum of any two of their sides was greater than the last side, than the third side. And that's what the triangle inequality theorem says. So we say here, we conclude, yes, a triangle can be formed with sides 4 first, 4, 9, and 10. It works. Let's do another example. Call this extra example 2. And this time let's use the side lengths of 8, 9, and 18. Do the same process. When we add two of these together, they must be larger than the third side we didn't add. So let's go. Okay, we'll go 8 plus 9, 8 plus 18, and 9 plus 18. The side we didn't use here was 18, the side we didn't use here was 9, and the side we didn't use here was, I guess I did those twice. Which one am I missing? 9 plus 18. There we go. So the side we didn't use was 8. If all three of these work, then yes, indeed, this could create a triangle. 8 plus 9 is 17. Doesn't work. 17 is not greater than the last side. No. These other two will indeed be greater. But right off, we found one that does not work. So if you find even one, then you know that it will not form a triangle. These side lengths are impossible to form a triangle. So we conclude, no triangle can be formed with sides, what did we start with? 8, 9, and 18. The triangle subtheorem, very valuable, a quick check to know if the sides you have will actually even form a triangle. So this leads us to the very end of 6.5. And this is actually part of the title of 6.5 that I gave you in the other video. And that is indirect proof. So, if you need to, pause this video, finish writing down this example, because I want to be able to have the room. I'm going to erase. So we call this a new form, and maybe we call it a type of proof. And this is called the indirect proof. More commonly known to most mathematicians, or when I say mathematicians, I mean people that have studied mathematics, even in a high school level, most commonly known by proof by contradiction. Contradiction. Well, what does that mean, proof by contradiction? Well, think of the word indirect. Indirect means that you're not going straight for it, you're kind of going around in a different route. So think of it this way. Let's say you're traveling from point A to point B. And maybe there's more than one option. There's the direct route, which might be like highway, Highway 90, since we kind of are familiar with those numbers. Highway 90, perhaps this is Wenatchee and this is Spokane. That's the direct route. But the indirect would mean that we decided maybe we're going to take, instead of Highway 90, we're going to do Highway 2. Now, if you know anything about Highway 2, when you're driving on it, it kind of varies on speed. It goes through a lot of towns. It's kind of twisty. I mean, it's pretty, but it's not very direct. It will take you longer to get from Wenatchee to Spokane. Now, does that mean that the proof by contradiction or the indirect proof is a longer type of proof? No. It just means that it comes to a conclusion, just the same as any other proof does, but it does it not directly. It does it indirectly. So let's try this out. And in fact, before we do so, let's talk about how it works. So how it works. And it works pretty good. The word contradiction means that you're coming across something that originally you said something and then you come to the conclusion that's the exact opposite. And you're like, it doesn't work. And so in fact, a lot of mathematicians use this symbol to represent contradiction. It's two arrows that have come together and they're like, well, we said this, but this happened and it doesn't work. Proof by contradiction, or simply the indirect proof. And so what you do, the first thing you do is you identify what you want to prove, and you temporarily assume that what you want to prove is false. And then you assume the opposite is true. Now, this will make sense in a moment when we actually apply it. So just for now, understand that we identify what we're trying to prove, and then we say, well, it must be false, and we're going to prove the opposite. We're going to assume that the opposite has to be true. And this is where step 2 comes in. You'll reason, you'll provide statements and reasons, things that back up why you're claiming such things. You'll reason through the proof until you reach a contradiction. Oh, that was terrible. Let's try that again. A contradiction. Ugh, that's still terrible. There we go. A contradiction. There's my little symbol, 2 arrows pointing together. A contradiction. So you reason, provide these statements, these proofs, and all of a sudden, that's where your problem happens. And it comes out to a statement that's a contradiction. And this brings us to the final step. Then, because of the contradiction, you conclude that the original statement was true. So because of what happened with the contradiction, you say, oh, all right, well, then it has to have been the other thing. Because I assumed the opposite, it has to be, the opposite ended up coming up with a contradiction. So then you say, oh, yes, the original thing was true. So let's try this out. So here's our example. This is example 4, I believe. So in a given triangle, there can be at most one right angle. So this is the situation. In a given triangle, there can be at most one right angle. Well, we want to prove if this is true or not. So we have to identify what we want to prove. Okay, well, there's the given. What is the given? It's any triangle. It's a triangle. So maybe it's triangle A, B, C. So given triangle ABC, what are we trying to prove? Well, we're trying to prove that triangle ABC can have at most one right angle. It can only have one right angle. So we identified what we want to prove. Now it says we have to temporarily assume what we want to prove is false. Okay, so we're going to start off our proof. We're going to say, I'll switch colors here. So this is 1. We're talking about assume opposite. Assume the opposite. Okay. Well, we're going to say, all right, assume triangle ABC has 2 right angles. That is, maybe angle A and angle B are both right angles. Okay, so we assume the opposite. We assume that there was two. This triangle has two right angles in it. Okay, now what do we do next? It says, reason through the proof until you reach a contradiction. All right, let's do that. So 2, we're going to reason. All right, well, what does it mean to be a right angle? Well, the definition of a right angle means the measure of angle A is equal to the measure of angle B, which is equal to 90 degrees. It's just saying that both of them are 90 degrees. Well, okay, let's reason a little further. What do we know about the sum of the triangles, some of the angles of a triangle? Well, we know from the triangle sum theorem that the measure of angle A plus the measure of angle B, let me write this on a new line because I'm running out of room. The measure of angle A plus the measure of angle B plus the measure of angle C has to equal how many degrees? How many degrees are there in a triangle? 180. Okay, well, we said already that the measure of A and B were 90. So let's just find what the measure of C is. Let's plug that in. So we would say, well, okay, the measure of A is 90 plus the measure of B is 90. And then we have the measure of C, which we don't know. Now let's subtract both of these 90s to the other side to find C. Watch what happens. 180 minus 90. 90. Now 90 minus the other 90. 90 minus 90. Oh. Measure of angle C is 0 degrees? Is that possible? It means it doesn't have anything. That means you only have 2 angles. It means you don't even have a triangle because you need 3. This is our contradiction. Therefore, then because of the contradiction, you conclude that the original statement was true. So 3. Therefore, any given triangle has at most one right angle. There it is. Proof by contradiction. You go through, figure out what it is, you identify what you're trying to prove, and then you temporarily assume the opposite and work it out. Then you try to reason on that. Try to see, does it make sense? If it does happen to make sense, then okay, you keep going. But in most cases, with proofs by contradictions or the indirect proof, you will come to a point where all of a sudden the math makes no sense. You come to a conclusion that is utterly wrong. Therefore, we get to go back to our original statement and say, yes, indeed, this original thing was true. In a given triangle, there can be at most one right angle. Now, maybe you perhaps are thinking at this moment, well, what if all 3 were right angles? What if all 3 were right angles? Well, you would come down to this point, but instead of just measure of angle A is equal to measure of angle B, you would also have measure of angle C, all three of them equaling 90. You would come to a spot where it says the measure of angle C is negative 90 degrees. Negative 90 degrees? Can you have negative measures inside a triangle that's supposed to add to a positive number of 180? No, indeed you aren't. You cannot do that. Again, you would come to a conclusion. So therefore, whether we decided there was 2 or 3 right angles, we would still come to a contradiction. Therefore, the original statement is true. Proof by contradiction. Now, if you're a little confused on this, go back in this film when we started talking about the proof by contradiction and listen again. Listen a little more carefully, that way you can set your notes aside, don't have to worry about writing anything, and just listen to the reason and the logic that happens. All right, this actually concludes 6.5. It also does conclude our chapter, chapter 6, which means next week, which most likely will be next Friday, will be our chapter test. When I am back on Monday, we will start our review. I will answer questions. We'll start to work some extra problems, and we'll spend the majority of next week doing review and clarifying any of the things that I could not answer because I wasn't here, so that we can do more one-on-one and we can go back and review things. So please take this weekend, think of what questions you have, write them down, and bring them with you on Monday. Make sure that you spend some good time with this lesson. I will be posting a homework assignment for this, and so you'll want to work on that homework as well. Be sure that you catch up on all of the homework for this class. That way, when we go into the first chapter test of the second semester, you know exactly what's going on. You've seen enough practice. You've done enough practice to be able to be successful with this chapter. Again, you can always email me throughout this weekend, even tomorrow. I will answer the email as quickly as I can. If you don't want to do that, I had posted on the whiteboard just over here earlier in the day that talked about being able to go and talk to Mr. Schwartz in room 355. You may also do that tomorrow at some point when you're free, before or after school, during lunch and during breaks. Please take some serious consideration to our notes to this lesson. I understand working from a video is a little more difficult, but I want you all to be very successful with this first semester test, chapter 6. Have a good evening, and we'll see you all on Monday.